How's everybody doing this morning? We're getting a little snow here in Chicago. I can't imagine what it's like up in Maine. I saw that going on up there. A few people from Wisconsin, Wheeling. You guys aren't too far away from our Bartlett facility. Awesome. Good to have you guys joining us. I know a lot of you guys join every time that we have one of these webinars. If you aren't able to make one of these webinars, please still register for them. I send out downloads of the videos, and I also put them on our YouTube channel, which I'll talk about here in a second. So here, if you guys search for ATI Metrology Training Channel, I'll come up with a shorter name for that one. You'll come up with our YouTube channel, and all of my past webinars are on this YouTube channel, and we're looking to build this channel into more stuff than just microview. So maybe CMM Manager software, maybe hand gauge, blueprint, things that will benefit you guys in your day-to-day operations of, hey, I'm looking to, what's the best way to measure straightness with whatever hand gauges. We'll have stuff going on there. So I'd love to hear from you guys and what other things you guys would like to have on this channel, just as a good reference, and also for maybe new employees or continuous education for your employees. We just want to be a resource to our customers. As some of you have seen emails come through, we have some upcoming events. Our calendar is pretty full this year with metrology training seminars that currently we have hand gauge training. So your basic hand gauges, micrometers, calipers, bore gauges, height gauges, blueprint reading 101, a good 4-hour class to get new employees up and running on reading blueprints, and also those who would like a review or have never gone through formal training before. It's a good 4-hour course to get up and running. And then our microview courses, our microview basic and advanced. And then last year we started a microview GD&T course where we go in depth of measuring GD&T, how to do it on many different sample parts. And the best part about in-person training is you can bring your samples and your blueprints and go with it. So coming up in March, we'll be in the St. Louis area, just a little west in Chesterfield, Missouri, holding this training seminar. And then in April, we will be in the Milwaukee area, I believe just a little west in Brookfield, Wisconsin. I saw a few from Brookfield, Wisconsin sign up for this webinar. So we'll be up there by you guys. And then a Chicago suburbs one. Haven't locked down the location, if it's at our office or somewhere off of 90 for you guys to be able to easy get in and out. But contact me, Dustin@ATIquality.com with any questions, or I wanted to show you guys our new website. I know you guys are here for microview training, but we launched a brand new website last October, and it has an events page that I want you guys to get used to going and looking at. It has our calendar and any trainings that we have offering at our facilities or regional. We do offer on-site training where we come to your facility, but if you're looking to, not travel up to Chicago, you can find a regional training seminar by you and the other classes that we offer. And this is also where you will find future microview webinars and expanding that into other free webinars here. So, bookmark that ATIquality.com/event-calendar to find all those, and you can see other training courses as well coming up. So I believe the last webinar we did was October. I don't know how about you guys, but it seemed like end of year 2021 and beginning of 2022 was pretty crazy, but we're getting back into it. But you can find this on the YouTube channel or email me for the download if your server doesn't allow you to get on YouTube. We talked about text fillers within your program, so able to do part numbers, lot numbers, all that kind of stuff. So it's exporting into your Excel sheets, into your SBC software, whatever you have that information you wanted to go out there. We talked about storing systems, so we could store stage squares, we could store planes off of the glass, all sorts of different things, and then working with DXFs So bringing in a 2D CAD file and being able to program off of a DXF on there. This month, though, I want to talk about programming similar parts. So I know a lot of you have assembly drawings where you're making a bunch of parts that fit together, so they have similar geometry to them. And I got two parts here that fit together that have similar internal features that I'll show you. Just, you don't have to write a brand new program if you have a similar part. And then we're going to build off of that program and show you guys insert here and insert at end. So we can add things to different locations in your program. For the past few webinars, I've talked about confidence in your measurements. So I get it commonly from a lot of people of how do I know that the tool that I'm using, how do I know that the lighting, the zoom that I'm using is the best for that measurement? I think there's a lot of things that I look at, and we're going to talk about using GD&T, even if there's not a straightness or circularity measurement onto it, but using that to build confidence in your measurements, lighting, the points view, and stuff like that. Set drive points. We'll talk about auto-generate drive points to make your programs quicker. And then also if it's not working correctly or you don't want to use it, how to erase that auto-generate drive points. And then working planes. We flipped the working planes before in some previous webinars to check chamfers. A lot of people think that the MicroView is just a 2D machine because it's using a camera looking down at the part, but we really can get 3D measurements out of the MicroView. Once you're really confident in your measurements, being able to flip the working plane, so we like to say, trick the camera that it's looking at it from the front or from the side of the machine to see these point values on there. So, go back and let's talk about programming similar parts. So I am going to drive around these parts and show you the geometry of the internalist parts. So we got a straight line, we got a radii, we got another straight line, radii, guess what's next? Another straight line, guess what's next? A radii. And then, so we have another part, if we come up here, that mates with that part, that overlays onto that. I'm not 100% sure of what the process is after this, if they weld them together, how they're joined, if one's free spinning, but I know that they have, looking at the assembly drawing, that both of these features are the same. So I would start with my simpler part here. We don't have all those teeth on the outside of it. So what I'm going to do is I'm going to start my program with similar features so I can use the same system when I'm measuring the next one. So for this, we've talked in the past of common systems, uncommon systems, and things that make the program run. Just as a review, a system is what makes your program automated. If I don't have a fixture, I need to write a semi-automated program where I'm going to measure a couple features to locate the part, and then the program will run after I set my origin and my skew. So I'm going to do an arc on this feature here. And whenever we create a system, we need three things: origin of X and Y, origin of Z, and a skew. So my arc has a center point. My line I can use for my skew. So my center point of my arc can be my origin of X and Y. My line can be a skew. And I'm going to switch over to my surface lights. And then anything that we do in Z, we want to go to a higher magnification. I'm going to keep it at 17 just for quickness here. But remember, anything we do in Z, so I just took a point and I used the focus point on this surface to put a point in Z on there. Just remember to always do a higher magnification. Many months ago, I talked about how to make your programs faster. If I go from 17 to 188, it takes about 5 seconds for the zoom to go all the way in. to that 188. So making your programs faster, I highly recommend planning out all your high magnification versus all your low magnification to be able to have your program not bouncing up and down in the zoom stops and adding tons of time to your program. So I'm going to start setting my system. I'll come down here to my system icons. I'll hit origin. Remember, it always automatically selects X, Y, and Z. So I'm going to deselect Z. I'm going to set my origin of X and Y to my arc. And you see that when I click on my arc, it gives me my center point. If you're a visual person, you could click point and click your arc, and it gives you that physical location of that center point. But I'm sure a lot of you have heard me say it before. If there's a faster way to make my coffee in the morning, I'm going to find it. And I like to say that if the less clicks I have to do in my program, the quicker I can program. So that's the way that I'm going to do it. Now we can see that everything else is grayed out. It wants my origin as Z. So I'll find my focus point. And then the last thing is my skew. If you've taken our basic training before, you've seen in the basic manual it says skew X to this line. I've started letting people know, and it's in previous webinars, and if you've taken my training, I just click skew, and if my line is within 45 degrees of my machine X or my machine Y, it'll know which one it is. I don't select X or Y because I've seen some issues. If you have one programmer and then you have multiple people running the parts, if it's semi-automated, if the programmer went left to right measuring this line, but then you go right to left when you run the program, your whole program will flip and it doesn't work correctly. So I've seen more success in semi-automated programs just clicking skew, as long as my skew is within 45 degrees of my machine X or Y, and then clicking that line. And then come down to this PCS view, straighten out my part. Now we have my system set up. So everything from here on out will be automated. So I'm going to go finish measuring my geometry. I'm going to use best edge points on here. You could also use F-scan arcs to be able to measure it. So I'll do a line down here. I'm going to do more inputs so I can tie two F-scan lines together. So doing that, more inputs ties those two together. I'm going to come down here. I'll do F-scan arc on my arc down here and tie those together with the more inputs tool. And you can see, since I have one feature, one arc, but more inputs, I can use multiple vision tools with that. We'll say that's good. Go to line. More inputs is still selected, so I can add this line. So now we got this part. Let's say we're good. This is what we need. We could do some angles between the two. So we get that angle. If you ever choose the wrong angle, side note here, you can always right click and go to edit solution to bring that guy back up to choose what angle you're looking for. Depending on where your system is and which direction the angle is going, if you ever see that it has the negative symbol on it, you can click this to make it positive, because angles most of the time will be reported as a absolute actual. So I hit that. And then while we're here, why not tolerance it? So let's call it 60 plus or minus half a degree. Some of you think half a degree is wide open. Some of you guys think that's really tight. I see half a degree is kind of normal. I've seen some companies have 5 degrees on an angle. I feel like you can make the angle any way you want, but it's all function, right? So let's say that that's our program. And then now we have a similar part down here with the same geometry that I would file, save this. Let's go to my desktop. Part 123A. Save that as a program. And then now I'm going to come down here and I'm going to run this program, but on my similar part. And even though my part's in a different stage, or a different location on the stage. Since it's the same geometry, it's a semi-automated program, so I can find it. If you've never run a semi-automated program before, these arrow or this crosshair is telling you where to place this tool. So all you have to do is just click that tool on there, hit continue, or you can hit enter, place that tool, continue, place the tool, continue. Now it moved on to line 2. The crosshair is telling me to go up there, place that one point, moves to the middle, places that point. Now I'll move down for my third point of my line. Now everything should run the same because it's the same geometry. Let's see how it runs. Got to do my focus point first. Continue. There we go. So now my part 1, 2, 3 -A or -B, I can save this as a new program, save as, switch to B. So now I have my 2 parts that are in the same family, but this program has more geometry to it, right? It has these teeth on the outside. So this actually, we're going to jump up to running with auto-generate drive points. What auto-generate drive points does is when we write a program and we place a tool, so I'm going to use line, and I'm going to use an F-scan line to measure this tooth right here. And then when I go to measure another line, when we run a program without auto-generate drive points, the camera is going to move to every single tool location that we used in our program. But we can see that we can fit 3 teeth in one camera view, which will total 6 tools. So instead of 6 movements of the camera, it's going to take 1 movement, able to get all those tools that can fit in the camera window. So your programs are going to run faster. So I'm going to do a point of intersection between these teeth because let's say my blueprint wants a distance between my intersection point and the center of this arc here. So we want that distance. We're going to go ahead and tolerance this guy. Since I skewed my program, I'm going to line that up. Right click, tolerances, or F3. Since I skewed my program, I can trust my Y distance because the distance is going in Y. But since I'm going to rotate this distance around this whole gear, I want to use my XY distance to tolerance, because if I tolerance my Y going this direction, once I get to these teeth, we're probably going to be out of tolerance because it's going to be taking what distance is in X. So these would be flip-flop. So I'm going to do my distance in XY. We're going to call it 1.26 plus or minus 5 thousandths. I'm in inches. That's good. Close. And before we rotate this feature around everything, I'm going to export that as well, my XY, so we can collect that data, send it to Excel, whatever we need to do. So everything that I want to rotate for my whole program is from line down to distance. So I'll right click, go all those features, go to rotate. The angle rotation of these is roughly 7.35. There are 49 teeth total, so I want to make 48 copies. And click OK. And once we rotate, let's try to slow it down a little bit. Actually, I'll make it fast for this one. Once we rotate, it rotates all those exports and tolerances with that. So now we can right click, remeasure, and we can see that it's individually moving to each tooth. And I mean, this program will probably take, let's just guess, a minute to run through all these. Could have seen that I could have cleaned these teeth a little bit more. So it's running through. The rotate's great because we didn't have to run and find, move the machine and find all these teeth and do the line intersection point. The machine's doing the work for us, so it's quicker programming. And quicker programming is good, but we want to do auto-generate drive points, and we want to make our program run faster, because if you're doing high volume, time is money. So I'm going to come to Tools, come down to auto-generate drive points, and we can select all features, or or we can have just certain selected features that we have. I'm going to go with all features and click next. So originally my program had 113 vision tools, had 113 snapshots. It's going to take those 113 snapshots, those 113 tools, and put them into 34 snapshots. So I'm saving estimated time of 67.8% runtime. Click finish, and it applies it to the program. So I'll do file save. Now I could rerun my program from the beginning, but it is semi-automated. So I'm going to go ahead and find where my lines start. So I'm going to highlight all of this. I'm going to right click, remeasure. And now we can see that we see the tools, but the camera is only moving to one location. On our first and second gen programs, it almost looks like it doesn't show the individual tools on there. So it could be concerning the first time that you run it, but it's placing all those tools. Gen 3 machines that came out 2 Octobers ago are showing every single tool on there. And I think MicroView is working on making this feature even quicker than it already is. So let's say that the MicroView thinks it can fit another tool over here, but it fails to measure. So let's go ahead and find this tool, be the next one. Let's think that it can fit these two in the same camera window. So if I move over, see how it's yellow, and it could fail to measure. So what I could do is I can right click in certain features, whatever might not fit in the camera window that, you know, MicroView thought that, oh, maybe it could fit in there. If it's not working your program, instead of clearing all your auto-generate drive points or re-rotating everything, we can right-click on individual features and go to either set drive point, or let's go to that tool. And you could clear the drive point if it was an individual one. So let's go ahead and find one. Clear drive point. So if those features weren't working in the auto-generated drive point location, you can erase just that individual drive point and it'll individually take those lines for those certain features on there, which is really nice because the auto-generated drive points, you know, 90% works great, but a tool just fits outside the camera window and it fails to measure, so we don't have to redo anything. We can just clear the drive point going on there. While we're here, so we got this program that we wrote, and I also wanted to talk about inserting here and insert at end. Let's say that we have this part in the fixture and we ran the whole program and we're like, oh no, we made it semi-automated. We want to make it fully automated. Not the end of the world. You can right click anywhere in your program and insert here, and you can see that dashed line that comes up in our features list over here. That's where we're writing in the program. I will say right up front, be very cautious when you're using touch probe because your move through points could get messed up or you forget where your move through points are. You really have to have confidence in your touch probe programming. Also, if you use any move through points with your vision to avoid any fixturing or tall parts, just be aware of that. But if I right click on my very first feature and say insert here, we're inserting at the very beginning of the program. So if you want to write a fully automated program, the first thing that we do is we come down to the recall button down here in the bottom of our construction icons, click recall. I'll find my reference system. So my reference system is the machine 00, or I could use my stage square. I'm unaware right now if this machine has been calibrated since the last time that I saved this. So we're going to go with reference system and click OK. And I'll right click insert at end. It's just a habit that I've always had since I started programming and using insert here, because if you forget to right click and insert at end and you start adding anything to your program, it's going to be where that dashed line is. So you really could mess things up in your program. Anytime that you measure anything, those features are looking at your most recent system. So everything below this system 4 down, if we look up at our parent system, is looking at system 4. If we have any other systems within our program and then measure things after that, it starts looking at that new system. But if we insert a system into our program, these features below it don't automatically look at that new system above it. We have to tell it to look at it. So these are still looking at our machine coordinate system up here, which is the lower left-hand corner of your machine. So what we have to do is everything below the new system we created down to the next system, we need to highlight, right click, and say set system to our new parent system. So now these features are looking at our parent system of 206. So now when I hit run, this comes up. If you make any changes to your program without saving it, this prompt will come up. If I click yes, all those changes I just made since the last time I saved it are gone. So I click no. And we can go to File, Save. Now we can run the program. And you can see our auto-generate drive points is working with those best edge points. It couldn't fit all those arcs in the same window. And now we're running around. Sometimes in MicroView can see 3 teeth, sometimes you can find 2. And one thing that I find interesting sometimes, once I run auto-generate drive points, run the program once, I wonder if it'll happen with this one, but if you go back and do auto-generate drive points again, sometimes it finds a couple features that it can fit in the camera window even better than it did the first time. We might not get it this time, but let's see. So yeah, we actually saved another 2.6% on something. And that was probably actually from, now I think about it, we cleared a drive point and now we just put it back onto there. But sometimes you'll see it without clearing a drive point. You'll be able to see even better results on there. So next I wanted to talk about having confidence in our measurement selections. Also, I forgot to mention earlier, if there's any questions you guys have as we're going along, pop them into the chat. I'll try to get to them. If I can get to them live on this webinar, awesome. If I can't, I'll follow up with you and post those questions later, either on the YouTube video or anyway, so you guys can see that as well. And at the very end of the webinar today, whatever time we have left, we'll do a Q&A that you can pop into the chat box as well. So let's talk about, save those changes. Let's talk about having confidence in our measurements. So I'm going to come over, find this other part here. I recently had a gentleman come up from Lafayette, Louisiana, and we were looking at this part, and this part had a lot of good features for lighting, choosing different lighting options, and having confidence in our measurements using the different lighting. So I'm going to get this in focus for you. So if you are from out of our normal territory, I'm normally traveling everywhere from Green Bay, Wisconsin to Minneapolis to St. Louis, all the way over to Indianapolis and everywhere in between. If you're outside of those borders, we still can do on-site training, or you guys can come to one of our facilities for any in-person training. But that's what that gentleman did, is he came up from Louisiana, had Chicago style deep dish pizza for the first time. But anyways, here we have this part that we have, it's a white plastic, and I think it's glass filled as well, part here. Couple things that I wanted to point out with this part is we had surface lights on, pretty, one color white. There is some gray value that we can see. Switching over to axial light almost makes it look like a metallic part. We get a little cloudiness going on, but it's still pretty clear. That any surface measurements, I actually might use axial light instead of surface light because I get more contrast between light and dark. This part's very just, plain white. It almost looks like a beige. So I might use axial light to get that more contrast between light and dark on there. But let's look at this diameter here. So my first initial thought, everybody asks me, how do I choose what lighting option for everything? I start with surface lights. If it's a surface measurement, so if we're going to be taking this diameter here, I start with surface. Take a look at it, see what it looks like. Let's measure a circle just to start getting some features and what it looks like. So we have this surface, this diameter that we're trying to measure here. I want to switch over to my slideshow. One thing with the insert here, if you're a hotkey person or you like using the keyboard, the insert button does the same as insert here, and the control insert, you can insert at end if you like using that. But having confidence in our measurements, I like to use GD&T, the points view, RMS error, and things that Microview gives us confidence in our measurements here. So when I measure a circle, we get the points view, and all 100 points with an F-scan circle get placed, and the green line is our best fit circle through all 100 points going on there. So I look at the points that are on the outside and the inside and see what kind of, where the points are fitting in my best fit. If they're really close to my best fit circle, I have confidence. We've talked about this before with having confidence in our lighting settings, but it also has if the tool is the right tool to use. Now, if we had big spikes going on and out, inside and out of the diameter, we might want to choose a couple different options. When we look in our software in our summary tab, a lot of you might have circularity turned off when we take a diameter. I like having it always on, and we can do that if we go to tools, configure summary reports, we can toggle it on or off. We can also toggle on RMS residual error to have that reading there. Now, if you have a lot of operators running the machines, and if you're handwriting your reports or your measurements, which hopefully if that frustrates you guys, give me an email. Let's find some solutions with exporting or an SBC software to add on to your Microview to get rid of handwriting your actuals on there. But I have these always on so I can view them as I'm measuring. But like I said, if you're handwriting your measurements and you have a lot of operators, you could turn these off so they're not writing down the wrong number. But right now we got about 2.5 thou of circularity going on in this diameter, which is pretty darn good. Even if this diameter isn't dimensioned on the blueprint with circularity, I like to look at it because if I know I'm under 5-8 thousandths, I have decent circularity that isn't controlled by engineering, so I feel confident with my measurement going on here. Now let's try to, if I bump this up a little bit, let's try to get a bad reading. Here we go. So now if we look at our points view, I'm going to right click, open large points view. We got these way far out outliers, and when I hover over them, it's hard to see on a white part, but there's a white crosshair that shows us where the points are being taken on there. So what I could do here, redo my lights, bring in my guard band. So I click on that dash line of any F-scan tool or any vision tool that you use, maybe make it a little smaller so it's more focused on that certain edge. My arrows are coming from the inside of the diameter out. We've talked about this plenty of times, that Microview doesn't need you to go dark to light or light to dark like some other vision machines do. If I switch it over, I jumped up, about 0.2 of circularity. Let's get rid of this guy. Bring it back over. I actually get a little better circularity, making it tighter with the arrows coming from the inside diameter out to measure that circle there. So just under 2 thousandths of circularity, that's pretty darn good. But let's see if we can get it better. If I go axial light, sorry about the noise if you hear that. The garbage truck is taking our garbage away. The axial light switching over here, we have a lot of gray value going on. And when I use axial light, the best contrast that the machine is seeing, the camera is seeing, is actually a smaller diameter in that feature right there. So I'm not even getting the right feature, and my circularity is 5,000. So we just jumped up from just under 2,000s to 5,500s. And I really don't trust that. So let's take a look more, see what kind of lighting options we can do. We can bump this up a little bit and see if that grabs that. But what I also could do is switch my arrows over, and it's still grabbing that inside diameter there. So let's see what other options we have. If we switch over to the outer ring light, update my lighting, switch my arrows back, I'm getting 1,007 here. So we made it even better than the 1,009 going on there. So when I'm doing my lighting, jump to surface lighting first, see what it's like. Try axial light, just in case, maybe that might work. But using the outer ring light on my micro view, so I don't have a lot of light going straight into that hole that could create a lot of gray value or even bright inside the hole, and I just have light coming from the surface hitting that hole, I'm getting a really good reading on that edge going on there, and it got better. We look at our points view. Points view looks pretty darn good. All the points are real close to my best fit diameter. I hover over a point, it's almost 7/10 out of best fit. That's pretty darn good. So that gives me confidence in my tool selection and my lighting selection of what's going on in that feature. And now, since this part has a lot of the same similar features, it took me a little while to determine what lighting option, but we can go through every single one and get the lighting that we want for those features. Now I got a little post here that we were seeing when we were measuring this post. We weren't really getting confident measurements in our diameter because we can see a lot of shadow up here on the 12 o'clock end and then less shadow down here at 6 o'clock. If I know that my part is flat on the glass, that's telling me that this post is actually bent. So we could zoom in a little bit, get that edge in focus, and start playing with our lighting. So this is where I would switch to a higher magnification, because going a high mag and I do a diameter here, circularity is not bad. Points view, we got a couple outliers going on here, but my diameter is undersized. It is, remember this was millimeters, supposed to be 2 millimeters going on here. And I was out of that because when we zoom in, we can see the points are, this is more probably oval shaped or egg shaped because we have the diameter leaning in one direction. So what we could do, we could play around with lighting and try to find better contrast for every side of our diameter going on here. So using the GD&T that you have, so same thing if we wanted to do a line and see if our tool, let's go over here to this edge. Seeing if our lighting is better or worse using surface, profile. If it's an outside feature, profile light's always going to be your best option to start with. Not always going to be what you end up with for your program. But when we do a line, we'll do more inputs. Looking at our straightness, switch back over to standard. Pretty good straightness going on with this part. We have confidence in the lighting. There's really no shadow going on. Let's look at our points view. Oh, that's the end of the part. We can right click, open up our large points view. This guy's a little crooked, but it actually might be some flash or whatever's going on with the part. But nothing's too crazy looking in this light. Almost looks like I imagine there might be an injector pin or gate, something going on here if they're kind of leaning towards the middle of the part there. So confidence in your lighting and tool usage, there's a bunch of different things that you can constantly be looking while you're programming. And then let's say that you're an operator, you don't do the programming. As you're running your parts, look at these kind of things and maybe suggest to the programmer on your team saying, hey, I was noticing these circles. They're all in. Lighting looks a little, off. And I noticed that our circularity was 7 thousandths. Maybe we could see if we could get more accurate measurements on these and maybe even more repeatable, because the lighting is what's going to make your program repeatable, having the best lighting for every single option or every single dimension that we have going on. The last thing I wanted to talk about today was flip working planes. So I want to stay on the inspec. I'm going to flip this part up. We can take a look at what we have going on. So I'm going to come over to this part and I'll visually show you guys. Let's find it. I always use profile light to find my part because you'll see that contrast immediately. And then once I find my part, I'll turn on whatever lighting that I need. So let's move this camera to get the surface in focus. Hit auto lights. So we can see that we have a plane here on both sides of this, and then this feature here in the middle is actually an angle going down. Couple ways that I could do this. An easy way of doing it is we would go high magnification. I'm going to switch over to axial light. That actually might not be good for that middle feature, but it'll be good for this here. Do my auto zoom. So I can create a plane. So I just click plane and let me do file new. So this schematic window looks good. I'll do plane. We could do a bunch of focus points around this plane, or we can use the area focus vision tool where I click once, starts creating a box, click again, and it places as many focus points in that box that it can see. The Gen 3 machines with the upgraded camera, the better camera that comes on the Gen 3 places a lot of focus points. It can see a lot of the contrast going on. So I'm going to do more inputs and I'm going to add 2 area focuses together. Now you should be at a high magnification doing this, but for this we'll stay at a low mag. I'm going to switch over back to my surface lights because that's kind of blurry going on there. And then I will do a new plane, turn off my more inputs, and let's do a plane here in the middle. So here, if we hold down our scroll wheel on our mouse and we start rotating the part, we can see that angle between the 2 planes, and we can do angle and do our 2 planes, and it'll give us that angle, that slope that's going on there. Now, sometimes I don't like doing that because it starts, that angle, those lines, it starts making my schematic window look very kind of messy sometimes, or a lot, cluttered, something going on there. So doing plane to plane angles, that works. But sometimes if we just had a small little edge here and we couldn't do a big line, what we could do is we could flip the working plane. Before we flip any working plane, we need to create a system. This must have been sample 3. So I'm going to turn on my profile light and I'm going to create a quick system on the edge of this part. I'll do line, line, intersection point between those 2. So now I have a line to skew to. I have an origin of X and Y. Let's set our origin as Z. Do a point of focus. This gets a lot of people a lot of times, and even me, where you click point and you want to go click focus point, but you can't. The last thing that I did was an intersection point, and construction icons stick on. So I got to deselect that and hit focus point. And then I can create my system. I'll do origin X and Y to my intersection point. I'll do origin of Z to my focus point, and I'm going to skew here. So we need an origin, a system in X and Y that we're able to flip. And then now what I'll do is I will do, let's go ahead and do high magnification here. And I'm going to do raw points in X and Y. When we did chamfers, when we did, I'm trying to think of what else we did with flip working planes, I'll show you what the need for flipping a working plane is, because when we take those points, MicroView knows that it has X, Y, and Z values. But if we created a line through those points, it's going to average the Z through those points and create the line. So for this line, for example, we're going to go down this little ramp that we saw to get the angle of it. And so when we move here, we can see, or we can click the side view, and we can see this line, and we can see this line. Now we haven't flipped a working plane yet. When I click line, more inputs, and I select all my points here, you can see it averaging the Z between all of them. And if I did a line up here, it's going to do the same thing, and it's going to probably be an angle of 0. So what we need to do before we create our actual features, we'll look at our PCS view so we know we're looking straight down at it in the camera window. I'm going to click System. I'm going to copy my system XY, and then I'm going to come down here to my flip working plane. I'll click it once, working plane YZ. I'll hit my PCS view. Now the software is looking at it from the side of the machine. So don't get it confused with the view. This is just looking at it in the schematic window, flipping the working plane to YZ. The software is actually looking at it sideways. And I'm going to rename this one System YZ so I can keep track of everything. Now I can do line, more inputs. And when I start selecting these, we're not averaging the Z anymore. It is averaging the X direction when it goes here, but that's fine because the angle is just going to be the angle looking in this direction. Now I can do line, more inputs is still selected. And now we have that. So now we can do an angle between those two lines, and we get the same angle we got with the planes. Now when we look at the top view, it's not that huge angle that we were looking at that makes our schematic window look all off. It's just controlled to where that feature is right in the middle there. When we're done flipping working planes, make sure you always go back and copy your system XY, hit PCS view so we can see how the software is looking at it. We're looking at it straight down again, and we're good to go with continuing our programming there. We've been covering flipping working planes on the last few webinars because it's something that a lot of new users aren't using because they're either unaware or it's just that pretty advanced kind of stuff before you get comfortable with the vision tools before jumping into flip working planes. But there's a ton of applications that we can use for flipping the working planes, and I want to kind of pepper them into every webinar just to give you guys confidence in using these steps of flipping the working plane. As we wrap up here, I want to leave a little time for questions if anybody has them. Remember, we have a bunch of seminars coming up in the next couple months. We have a bunch throughout the rest of the year. So you can go to that calendar or shoot me an email and I can give you some information. Check out our YouTube channel with a bunch of videos on there, previous webinars if you missed one or want to review one. If your server doesn't allow at work to get on YouTube, let me know and I can get you the actual downloaded videos for you. So thank you everyone for joining in today. If you don't have any questions, feel free to log off and get back to, I'm sure, a lot of inspection, PPAPs, FAIs that you guys have going on. Feel free to pop a question into the chat box if you have one. Thank you again for joining today, and email me with any question that you guys have. I'm here to support our customers, help you through any problems that you guys are having. You can send me your microview program. You can send me a blueprint, send me a picture of the part. I can assist you on what system to set up, how to do it. And if you feel like your team could benefit from some of our structured courses like basic and advanced, feel free to reach out. Or if you want to schedule 4 hours of just application-based training where I come on site, we have your parts, and we sit there and train through writing programs, we can do that as well. So if it's not one of our structured courses and we want to customize the training, we don't charge anymore for that custom title onto it. We just want to make sure that you guys are measuring parts the most efficient and accurate way using your machines. Microview, blueprint, hand gauge, anything that you guys have going on, reach out to me. But thanks again. Enjoy the rest of your week, and I'll stick on here for a few more minutes to see if any questions come through. If not, have a good day.